Conquering Mars, a phrase that evokes images of heroism, ambition, and the relentless pursuit of the unknown. But beyond the poetic allure, the journey to Mars is not a mere trip. It is a battle, a fight against the endless void, against lethal radiation, and perhaps most daunting of all, against the limits of human endurance. Every step into deep space is a gamble. Every moment an edge between triumph and catastrophe. The distance to Mars is not just measured in kilometers, but in months of isolation, in the weight of solitude and the magnitude of deadly challenges. Can we shorten this journey? Can we build a home in the cosmic wilderness? And how do we keep our minds intact when the world as we know it disappears from view? Today, we unravel the answers. We explore the vision and strategies of global powers, their spacecraft designs, the strengths and weaknesses of their approaches, and the daring bets they make. We delve into breakthrough solutions for speed, asking why new propulsion is urgent and which emerging technologies promise to revolutionize space travel. We confront the invisible killers, the radiation storms that threaten every astronaut, and examine the shields that might save lives. And finally, we confront the greatest challenge of all, the survival of the human spirit and body on a journey that tests every limit. The race has begun, and at its center are two giants, SpaceX and NASA. SpaceX, led by the audacious vision of Elon Musk, is committed to total reusability. Starship is not just a vessel, it is a paradigm shift. Musk imagines interplanetary travel as affordable and accessible as commercial aviation, aiming to transform spaceflight from a rare event into a routine possibility. Yet, this ambition comes with risks. Starship is still in its experimental phase, and the unforgiving journey to Mars poses threats no prototype has yet faced. Can a ship designed for reusability endure the relentless battering of interplanetary travel? And what of the dream to build a self-sustaining colony on Mars? Can it truly become a reality, or is it still a fantasy? On the other side, NASA's Artemis program offers a more conservative strategy. Rather than leaping directly for Mars, Artemis treats the Moon as a proving ground, a safe haven close to Earth, where new technologies and systems can be tested. This approach reduces risk and builds a foundation of knowledge to support future missions. But it comes at a cost: enormous budgets and political vulnerability. International tensions, shifting priorities, and funding uncertainties have derailed ambitious projects before, as with ExoMars. For NASA, the challenge lay not only technological, but also maintaining long-term commitment in a world of ever-changing interests. This race is not just about engineering brilliance. It is a contest of political stability, financial resilience, and strategic vision. Yet, regardless of who reaches Mars first, there is a shared challenge that looms over every mission: the journey itself. 6 to 8 months aboard a spacecraft exposed to cosmic hazards and the psychological strain of isolation is no trivial ordeal. Radiation builds up, muscles waste away, and minds fray under the pressure of confinement. The solution? Propulsion technology that can slash travel time and transform the very nature of interplanetary missions. Imagine a nuclear fusion engine, a marvel that could cut the journey to Mars down to just 2 or 3 months. Companies like Pulsar Fusion are racing to turn this dream into reality. Fusion propulsion doesn't just promise speed, it offers efficiency, with far less fuel required and far greater thrust than conventional engines. Such technology could change everything making the journey not only faster but safer. Plasma engines, though demanding vast amounts of energy, are another promising avenue, offering powerful acceleration that could one day make Mars trips routine. The race for speed is not just about convenience. It is about survival, strategy, and the unlocking of new frontiers. However, speed alone cannot safeguard human life. In the vast emptiness of space, radiation is an ever-present, invisible threat. Galactic cosmic rays and solar particle events bombard everything beyond Earth's protective shield, carrying the power to damage cells, weaken immune systems, and inflict long-term harm. To defend against these lethal forces, engineers are developing multi-layered shields. The first line of defense is an magnetic field, a vast artificial magnet that deflects solar storms and cosmic rays, mimicking Earth's own protection. Inside the hull of the spacecraft is crafted from advanced materials rich in hydrogen and samarium oxide, absorbing and scattering radiation before it can reach the crew. These layers work together, forming an armor, not just of technology, but of hope, a safeguard for the pioneers who will risk everything. Yet the final and perhaps greatest challenge is not technical, it is human. The body and mind are not built for the void. In microgravity, bones lose density, muscles weaken, and the heart struggles to adapt. To survive, astronauts must follow strict exercise regimens, use artificial gravity systems, and constantly monitor their health. But physical survival is only half the battle. Isolation, cramped quarters, and the fading sight of Earth can erode morale, breed anxiety, and spark conflict. The solution is thoughtful design. Spaces with windows to offer views of the cosmos, flexible living areas that allow privacy, and careful selection of crew members with empathy, resilience, and shared purpose. Mental health is not a secondary concern. It is a primary requirement for mission success. Ultimately, the journey to Mars is not a single leap, but a symphony of innovation. Nuclear fusion engines, magnetic shields, adaptive habitats, all must be orchestrated to serve a singular goal: the survival and flourishing of humanity beyond Earth. This is not just a technical challenge, it is a call for global cooperation, sustained investment, and a recognition that human factors are at the heart of every design. Only by embracing these truths can we hope to make the dream of Mars a reality. The call is clear. Let us unite, invest, and put people first. The next chapter of history awaits, written not just in technology and ambition, but in the resilience of the human spirit. Together, we can conquer Mars. Together, we can shape the future.